Any of you who missed this, or if you didn't quite get all of it, in dealing with simplifying absolute values, and let's look at the difference between these two radicals. All right, when you're looking to reduce these using the rules that we just talked about, right, you're looking to remove groups of 2, whatever the index is. So the square root of x to the 8th can be reduced to x to the 4th. And now, because it was an even indexed radical, you do have to consider the possibility of it having absolute values. And so if you look at the original form, a negative number taken to a power of 8 is a positive. So it's possible for our original form to have a negative for x. And when we simplify it, if the x is negative in this simplified form, is it guaranteed that our value will never be negative? A negative to an even power is positive. So this is guaranteed. We don't need to include any absolute values on it. It's already guaranteed by the powers will take care of that sign. Okay? But compare that to what happens in the square root of x to the 10th. Again, you can either pull out powers or groups of 2, or you can cancel. Our index of 2 goes in once, index or 2 goes into 10, 5. So this reduces to x to the 5th. If we look at the original form, if x is a negative and we take it to a power of 10, that becomes a positive, which we can then square root to get a positive value. So it is possible, again, for x to be a negative number. So we need to consider what happens in our simplified form if x is negative. Well, a negative taken to the power of 5 is going to be a negative. And we know that that can't happen. A square root has to yield a non-negative value. So in order to ensure that that's met, that condition's met, we have to put absolute values around the x in that case. Okay, what happens when we're dealing with the square root of x to the 9th? Okay, so here, when we simplify it, we have an index of 2. So how many groups of 2 can we remove from a 9? We're going to remove 4 groups of 2 with how many groups left? 1. So here's our simplified form. Okay, we need to consider, though, if x was negative in our original form, is that even possible? You take a negative to an odd power like 9, and you get a negative, which is then under a square root, which cannot exist. So x can't even be a negative. So we don't even need to check that because that restriction is identified in the simplified form as well. Here, x can't even be a negative. So you don't need to worry about even checking for absolute values because x can't even be a negative at all. And let's compare this then to this final example, x to the 7th, y. In this particular case, when we go to simplify, we're looking for groups of 2, whatever the unwritten index is here. How many groups of 2 can we remove from 7? 3, and that leaves 1x inside the radical. The y is already fits the pattern or fits the rules. We leave it inside. And so here's our simplified form. And we look to see in our original form, is it possible for x to even be a negative? Well, a negative to a negative power is still going to be a negative. So the only way that that could exist as a factor in here is if another factor canceled it out, which means if x is negative, it's directly related to y being negative. They're dependent on each other. If one's negative, they're both negative. So what we have to do is we have to test that possibility in the simplified form, that if they're both negatives, does this form guarantee we'll never have a negative solution? Well, inside the radical, it works out. A negative times a negative is a positive, so we don't need any symbols or any absolute values inside there. But on the outside, because we would be taking this negative to an odd power, we do need to include absolute values to ensure that we're never going to have a negative solution.